So welcome to part 3 of question 1. Okay, so this question had a bit of a problem. We asked the wrong question at the wrong time. We were supposed to give it a 200 Newton force as the weight of this block, and then the task we had was to actually find the components of the forces. Now it so happened that we asked it at the wrong time, but nevertheless we are supposed to solve it, and we will try. It's a wrong question, I must say. Maybe. Okay, let's just skip it for now. We'll get back to it later. Right. Okay. So we'll go to question 4. Okay. So this question 4, again, we are supposed to find the resultant of this force. So with this, all of us must really be able to see and know where the resultant will be. So you resolve each and every force in its component, and then you are going to add the Fx, the Fy's, and the Fz together. Okay? So let's just do that. Okay. So we see that we need to express F1, F2 and F3 in Cartesian vector form. Okay, then sort of add them. That will give us the x component of each, and you will have the Cartesian vector form, and we'll find the direction angles of the resultant. Okay, so going forward, F1, as I can see, is equal to the x component is 4/5. This small triangle I've been given here, so there is 5 here, then there's 3, and then there's 4. So the ratio, this triangle inside here is showing the ratios. So the x component ratio to the hypotenuse is 4/5. So I'll say 4/5 times 90, which is the magnitude of F1. This is I, plus in the y-axis there's nothing because it's in the z plane. In the xz plane, that's where it is. So I'll go there. You have 3/5 times 90, which is in the k direction. Okay, and this will be, we have already started on the wrong portion. We'll cut our margin there so that we work with this side. I'm also forgetting to reset my screen. Okay, so 4/5 we are talking of, okay, we have 72i, okay, plus we have 54k. Put it newtons there. For my F2, okay, F2 I've been given those angles to assist me, okay. So I know that this will, for the x-axis, it will be what? First I'll need to find f prime, which will be equal to f2 cos 60. Okay, that's my f prime. Now to find the x component, this will be sine 45 I, and that's my x component plus my y component, which is also by observation positive. It will be the same, f2 cos 60, giving me this is giving me f prime times cos 45, okay, 45 degrees. This is j plus the k, which is simply f2 sine 60 degrees, and this will come to 150 times cos 60 and 745. So I have 53.033I. I've already replaced my F2 with 150, which is this one here, and I've already done everything, so I'm having 53.033I, and then plus, then I have again, just do it again, 150 times cos 60 times cos, which will be the same. Yes, it's 45 degrees, so it has to be the same. 53.033J, and then I have plus, this will be 150 multiplied by some 60, which will be 129.90K. So that's my F2 in Cartesian form. My F3 in Cartesian form as a vector, it has only the z component of 200, so it's simply 200k, sorry, not I, k, and it is positive by observation there. So my FR now, which is the resultant, which is a vector, I'll just sum the i's together. So this and the j's together, so you have 72 plus 53.03. This will be my I, and then plus For the y, I only have 53.03. This will be j, and then plus I have of all these forces, how come they are all positive? You have to be careful with the signs, the negative and positive, because they can make your answer entirely wrong. Okay? So for the k, now I have my 54, then I have my 129.9, and then I have my 200. This is the k, and the Cartesian form of the resultant is 72, which is 125. We'll just leave it at 125 to one decimal place, and then plus 53 j, and then plus this will be 54 plus 80 plus 53, no, plus 200, which is giving us 384k. So our FR in Cartesian vector is that one. Voila! At least we are almost there. Okay. Now let's come here to see if we can. So 125 plus 53 plus 384. So you see my FRX is equal to 125, FRY is equal to 53, FRZ is equal to 384. I found that are my components of X, Y, and Z. Awesome. Now, we need to find the direction angles. Okay? So I need to find the magnitude of FR. So I'll say FR now magnitude is equal to the square root of 125 squared plus 53 squared plus 384 squared, which is equal to 125 plus this will be 407.2.3. 407.3. Let's leave it there. Okay, so then my alpha is equal to cos inverse of 125 over 407.3, which is equal to, this will be 125, sorry, This is 72 degrees. 72.1 degrees. Beta is equal to cos inverse of 53 over 407.3, which is equal to that sounds too much, but okay. 82.5 degrees. Gamma is equal to cos inverse of 384 over 407.3, which is equal to just equal to 19.5 degrees. Those are the answers for the second part. So we found the magnitude first, and then we get the direction angles. So even though the writing is not so nice, but please try to follow through, and we'll try to improve these videos. Perhaps maybe I need a proper writing stylus, but for now let's do with this.